Hi, in this video, I'm going to show the example of hydrogen bonding and hydrophobic interaction. I will use hemoglobin to visualize the molecule or hydrophobic and hydrogen bonding interaction. We'll also see the interaction between porphyrin and the protein. First, we are going to get the PDB. I will enter the PDB code here, 3BCQ. We downloaded the hemoglobin structure using PDB ID from Protein Data Bank. You can see the 4 subunits and 4 porphyrin molecules. I'm going to display the sequence here. We don't need all the 4 subunits, so it complicates the visualization. What I'm going to do here is remove the 3 subunits and some of the hemoglobin water molecules associated with this. As I said before, you can use this sequence button. So first chain I'm going to leave. I'm going to select the second chain onwards up to the 4th chain. Once you select, use the selected one on the right side here, remove atoms. So now you can see that this only one chain is displayed here, and this hemoglobin oxygen belongs to this, so we don't want to remove that. So I'm going to remove other hemoglobin oxygen which are outside this molecule, remove the atoms. And these water molecules also belong to this, so I want to remove the other water molecules. Hold the shift button, go to the other end, remove the atoms. So now we have only one chain of hemoglobin with water molecules. I can reset that and make it to look brighter. So you want to visualize the binding site and the interaction there. For that, what we'll do is go to the action button here, reset ligand site cartoon. When you do that, using this option, you can see that the ligand site here is highlighted and zoomed in, and the amino acid residues which are interacting with the ligand or neighboring residues are highlighted in sticks. So this is the porphyrin molecule which is holding the oxygen here. So this is the oxygen. So the porphyrin at the center has nitrogens, forms a coordinate bond or dating bond. Apart from that, nitrogens within the porphyrin, the 2 histidines hold the oxygens together. So I'm going to label these molecules. So for labeling, you go to 3BCQ here and L. So I'm going to label the residues with 3-letter code. So immediately you can see that amino acid leucine 92. You can see that leucine 84, leucine 33, and so on, all are labeled. And these are histidine molecules which are holding the oxygen, one from top, one from the bottom. If you read the biochemistry, you will know why this is at an angle to hold the oxygen up at a particular strength. Now, what we're going to do is from the protein side, you can see that there are a lot of amino acid residues are highlighted. If you go and look at them, this is a leucine, this is a leucine, many leucines here. There's phenylalanine here, you can see, and many leucines, and there is a tryptophan here and phenylalanine here. So you can see that most of the protein interior, which is held together, uh, is what we call hydrophobic interaction. These are hydrophobic functional groups which create a hydrophobic cavity here. So the porphyrin with the aromatic ring system here is hydrophobic. There is a small CH3 group also at the end, and the free electrons here with the alkyl group here form a hydrophobic. So to hold that hydrophobic organic molecule, you have hydrophobic amino acids which create a hydrophobic interaction. And at one end here, you can see there is the oxygen here, and these are water molecules. The yellow dotted line is hydrogen bonding. So if you zoom out, you can see that this is the exterior of the protein. Exterior of the protein is surrounded by water molecules, and the water molecules hold some of this porphyrin as well as some of the amino acid residues with hydrogen bonding. So that is shown as the dotted line. Hydrogen bonding has a particular geometry, and hence you show as a dotted line, whereas a hydrophobic interaction is just, it doesn't like water. So you can see that the water molecules are only here inside the deep inside the protein. There is no water molecule because hydrophobic amino acid residues. So all these leucines, phenylalanines, tryptophans create a hydrophobic environment for the porphyrin to stay binding inside the protein. And hydrogen bonding are at the basically forming some hydrogen bonding pattern, the water molecules or the amino acid residues on the outside. Hope this gives an idea about what is a hydrophobic interaction and hydrogen bonding, how we can visualize that.